Ni kita akan discuss berkenaan dengan topik limit, topik L'Hopital's rule and indeterminate form. Okay. So soalan 19 So soalan 19 limit x approach to approach to 0, and we have this function sin apa tu? Sin 3x over sin 5x. Okay, sin 3x over sin 5x. Okay. Alright, so based on this limit s approach to 0 for sin 3x over sin 5x. So here it is approaching to 0, and for sin 5x, where x is pushing to 0, we have 0 also. So maknanya dekat sini, bila you cari sin 0, 3 times 0 is 0. So sin 0, it is approaching to 0. Sama juga yang bawah ni lah. Kalau you find the limit for sin 5x, where x is approaching to 0, then we have 0 here. So here we can say that this is about indeterminate form, type of 0 over 0. So bila kita dapat yang ni, kita kena gunakan L'Hopital's rule. Okay, L'Hopital's rule. Alright, so in L'Hopital's rule, we need to differentiate for numerator and denominator. So now we need to apply L'Hopital's rule. Okay, so apply L'Hopital's rule, limit x approach to 0. We have sin 3x over sin 5x. So it is also equivalent with limit x approach to 0. Okay, so derivative respect to x on sin 3x over derivative respect to x on sin 5x. So you differentiate, then we will have a limit x approach to 0. For derivative respect to x on sin 3x, we will have 3 cosine of 3x over, okay, so find derivative respect to x on sin of 5x. We have 5 cosine 5x. Okay, so sekarang kita cek limit dia. So limit limit x approach to 0 for 3 cosine 3x. So untuk cosine 3x, where x is approaching to 0, so we have cosine 0. So cosine 0, it is approaching to 1. Okay, ni pun sama lah, cosine 5x, where x is approaching to 0, so we have cosine 0. So cosine 0 is 1. So 3 times 1 is 3. 5 times 1, we have 5. Okay, so therefore the limit for x approaching to 0 for sin 3x over sin 5x is 3 over 5. So jawapan dia adalah, dapat tak 3 over 5?
Dapat.
Dapat. Okay, very good. So limit x approaches to 0 for sin 3x over sin 5x equals to 3 over 5. Okay, very good. Ada soalan tak? Any question?
Ada.
Okay, ada. Bagus. Right, so next question, number 28. So 28 is a limit x approach to infinity for x cubed over exponent x squared. Okay, we have a limit x approach to infinity for x to the power of 3 over exponent x to the power of 2. Okay. Okay, so first we need to find its limit. So limit x approach to infinity for x to the power of 3, it goes to infinity. Okay, so infinity to the power of 3 goes to infinity. So next, limit x approach to infinity for exponent x squared. Then we will have exponent infinity. So exponent infinity is infinity also. Okay. So now we have this indeterminate form, type apa tu? Infinity over infinity. Okay. So next we need to apply L'Hopital's rule. So bila you nak apply L'Hopital's rule, you kena letak dekat situ apply L'Hopital's rule You need to mention that you apply L'Hopital's rule. Ada sebab. Okay. Sebab dia adalah limit x approach to infinity for x to the power of 3 over exponent x squared equivalent with limit x approach to infinity for the derivative respect to x on x to the power of 3 over derivative respect to x on exponent x squared. Yang ini. Okay, so definition yang ini hanya untuk L'Hopital's rule saja. Okay, hanya untuk L'Hopital's rule. That is why you need to mention that you apply L'Hopital's rule. Jelas So yang ini hanya untuk L'Hopital's rule sahaja. Sebab tu you kena mention apply L'Hopital's rule for this one. Which is limit x approach to infinity for derivative respect to x on x cubed over derivative respect to x on exponent x squared. Okay, sebab tu you kena letak situ apply L'Hopital's rule. Okay, so now we differentiate for numerator and denominator. Selesaikan. Then here we will have a limit x approach to infinity. So differentiate respect to x on x cubed, we have 3x squared over. So this one differentiate exponent x squared. We will have so this one exponent x to the power of 2 multiply with the derivative respect to x on x to the power of 2. Okay, so it is also equivalent with limit x approach to infinity for 3x squared over 2x times exponent x squared. This is how we differentiate for exponent x squared. Okay. Right, so next we find this limit. So limit as approach to infinity for 3x squared, we have infinity. So this one is also infinity. So here we need to apply L'Hopital's rule for second time. Okay, so apply L'Hopital's rule, part 2. L'Hopital rule for part 2. Okay. So we have limit x approach to infinity for 3x squared over 2x exponent x squared. It is equivalent with limit x approach to infinity, derivative respect to x on 3x squared over derivative respect to x on 2x exponent x squared. Okay. So you akan dapat limit x approach to infinity. You differentiate respect to x on 3x squared. We have 6x over. Yang ni you guna gunakan product rule lah. This one we use product rule. Okay. Sebab dia ada x and exponent x squared. Okay. So product rule uv prime plus vu prime. So we have a 2 exponent x squared and then plus 2x. So jadi you differentiate, you akan dapat 2x. So 2x times 2x, we will have 4x squared exponent x squared. Okay. Betul double check. Check you punya jawapan. So now we have limit x approach to infinity. Oh ya, yang ini kita boleh gunakan tak boleh. Okay. So now we have this one, you cari limit. We have infinity, yes. Yeah.
Kenapa? Jap. Dah buang ke X? Oh, dah buang. Buang ke X?
Mana?
X sudah buang. Dah
Kat
buang
mana
kan?
sini?
Dah buang. Kan dia jadi 6x kan?
6x
3x square.
2x exponent x squared. So yang ni kalau kita gunakan product rule is a
Dia jadi tu.
u plus v u
Kenapa tak
prime.
ada buang 2x tu, madam?
Kenapa tak buang? Kenapa tak ada?
Kan dia 3x square over 2x ex square kan? Kenapa x tu tak ada buang ke? Kan 3x square over 2x. X buang jadi 3x. Boleh?
Boleh. Betul. Boleh simplify lah. Okay, good. Alright, so yang ini, okay, yes, we can simplify. Kalau you tak simplify, you akan jadi macam ni lah. So, dia akan jadi lebih rumit. Kalau you tak nak simplify, you need to apply product rule. Okay? Alright, so now for this one, we can simplify. Very good. Tak simplify pun betul, tapi dia akan jadi lebih panjang lah. Dia punya function tu. Okay? Alright. Okay. Alright, so this one we can simplify. Then we have 3x over 2 exponent x squared. Okay, so we have limit x approach to infinity for 3x over 2 exponent x squared. Okay, right, so now we find the limit. So the limit here is infinity and the down here is also infinity. So here we have infinity over infinity, which is indeterminate form, type of infinity over infinity. Okay, so next we need to apply L'Hopital's rule for third time. Dia macam ni lah, selagi masih ada lagi indeterminate form, whether infinity over infinity or 0 over 0. So we need to apply L'Hopital's rule. So this one is a third time lah. Okay, so now we have limit x approach to infinity for 3x over 2 exponent x squared, equivalent with limit x approach to infinity, derivative respect to x on 3x over derivative respect to x on a 2 exponent x squared. Okay, so you differentiate for numerator and denominator. And here we will have differentiate respect to x on 3x. We have 3 over, so this one, you differentiate any 2 exponent x squared, multiply with the derivative respect to x on x squared. Ini. So you akan dapat apa? 2x. 2x Okay, so find limit. So limit as approach to infinity for 3, we have 3, but the constant. And for the down here, we have this one, 2 exponent x squared times 2x, but x is approaching to infinity, we have infinity. Okay, so based on this, 3 over infinity, it is approaching to 0. Okay, so therefore, limit x approach to infinity for x cubed for x to the power of 3 over exponent x squared, it is equivalent with 0. Okay, so ni jawapan dia. Dapat tak jawapan dia ni? Kosong jawapan dia. Ada yang dapat jawapan lain tak? Kelas okay
Okay.
Okay, good. Alright. So next, number 33. Okay, so 33, we have a natural log of x over x squared, where x is approaching to infinity. Okay, natural log of x. Okay, so limit x approach to infinity, natural log of x over x squared. Okay, so cari limit. Then here we have infinity over infinity. So apply
Meja.
L'Hopital's. Yes.
Soalan tu tak buat. Medan suruh buat soalan lain. 36 dengan 48.
36 dengan 48.
48.
Okay, tak apa kita buat soalan.
36 dengan 40.
Okay, okay. Okay, kita buat ni. 36 and 40. So this one tak. Okay, 36 and 40. Alright. Okay, so question kita 36. 36 is limit x approach to infinity. Exponent x over 2. Exponent x over 2 over x. Betul? Okay, betul. So ini simple. Tengok je simple. Okay, so limit x approach to infinity for exponent x over 2. Okay, so x over 2, where x is approaching to infinity, so this means that infinity lah, infinity over 2. So infinity over 2 is infinity. So here we can say that limit x approach to infinity for exponent of x over 2 is infinity. And for the denominator here, it is also infinity. Okay, so this one is about indeterminate form, type infinity over infinity. So now we need to apply L'Hopital's rule. Okay, so L'Hopital's rule, limit x approach to infinity for exponent x over 2 over x, it is equivalent with limit x approach to infinity, derivative respect to x on exponent x over 2 over derivative respect to x on x. Okay, so differentiate. Then here we have limit x approach to infinity. So differentiate ni kita akan dapat dapat apa? 1 over 2 exponent x over 2. Betul tak? Double check ni.
Betul.
Betul. Okay, so derivative respect to s on x, we have 1. So here we find the limit. 1 over 2 exponent infinity, which is infinity over 2 is infinity. Then kita akan dapat infinity. Okay, so here the answer is infinity. So therefore, we can say that limit x approach to infinity for exponent x over 2 over x, it is equivalent with infinity. Okay. Right, boleh tak? Dapat tak infinity?
Dapat.
Okay, very good. Boleh kita tengok teruskan 38? Ada soalan tak untuk yang ini? 36. Any question?
Tak ada.
Tak ada. Okay. So now kita tengok 40. Arctangent. Arctangent. Limit x approach to 0. X over arctangent to x. Tangent inverse lah. Okay. So this one limit x approach to 0 for x. We have a 0. So this one it is also 0. So yang ni you plug in your calculator. Tangent inverse to x. So x is approaching to 0. So means that 2 times 0. So 2 times 0 is 0. Then in calculator is also 0. Okay, so here we can see that it is about indeterminate form, type of 0 over 0. So macam biasalah, apply L'Hopital's rule. Okay. Limit x approach to 0 for x over tangent inverse of 2x, equivalent with limit x approach to 0, derivative respect to x on x over derivative respect to x on tangent inverse of 2x. Okay. So ini you differentiate, you akan dapat differentiate respect to x on x, we have 1 over, okay, differentiate respect to x on tangent inverse 2x. Apa jawapan dia? Differentiate. Ha. Derivative inverse trigonometric. Hafal tak? Boleh tengok kat situ. So derivative respect to x on tangent inverse x is 1 over 1 plus x squared. Okay, 1 over 1 plus x squared. Okay, so 1 over 1 plus x squared, we have 1 over 1 plus 2x to the power of 2 dekat situ. Okay, x squared. So our answer is 2x. Alright, 1 over. Ni 1 over 1 plus 2x times 2. So it is also equivalent with limit x approach to 0 for 1 plus 4x squared. Okay, so cari limit. So limit x approach to 0 for 1, we have 1. So limit x approach to 0 for 4x squared. So x is 0. So 0 times 0. 0 power of 2 is 0. So for this one, we have 0. Okay, so therefore, the answer here is 1. So, limit x approach to 0 for x over tangent inverse of 2x, it is equivalent with 1. Okay, boleh? Ada soalan?
Boleh.
Boleh. Okay, yang lain okey ya? Kalau boleh, kita tengok yang lain. Okay, 36 dah, 40 dah. Okay, 44 dah buat dah. 44 ni, it is about indeterminate product. Indeterminate product. Okay. Right, so kita tengok 44. Limit as approach to 0. With the function here is x to the power of 3 times cotangent x. Okay. So kalau you tengok yang ini, okay, so x cube, x approach to 0 is 0. So cotangent x is, ni cotangent x apa? X0, cotangent 0. Apa jawapan dia? Infinity. Infinity. Okay, so mana yang tak tahu macam dapat infinity tu? So as you know, cotangent x is about 1 over tangent x. Okay, so x approaching to 0. So means that tangent 0. Tangent 0, tangent x is approaching to 0. So you kena cari tangent 0. So tangent 0 is 0. Okay, ni I letak limit x approach to 0. Okay, so here we have 1 over 0. So 1 over 0 is infinity. So that's why we have infinity here for cotangent x, where x is approaching to 0. Okay, right. So this one is about indeterminate product. Okay, right. So if we have indeterminate product, then we need to rewrite into a ratio. So from here, limit x approach to 0 for x to the power of 3 cotangent x. It is also equivalent with limit x approach to 0 for x times 1 over tangent x. Okay, and then you combine, then we will have a limit x approach to 0 for x over tangent of x. Okay, so now limit x approach to 0 for x, we have a 0. So limit x approach to 0 for tangent x, we have 0 also. So this one we need to apply L'Hopital's rule. Okay, so apply L'Hopital's rule. So here we have limit x approach to 0 for x over tangent of x. It is equivalent with limit x approach to 0 for the derivative respect to s on x over derivative respect to s on tangent of x. So it is also equivalent with limit x approach to 0. Derivative respect to s on x, we have 1 over tangent x. We differentiate respect to s on tangent x. Kita akan dapat secant square x. Okay. Okay, so now we have 1 over secant square x, where x is approaching to 0. Berapa jawapan dia? So secant x, it is also equivalent with 1 over cosine. So 1 over cosine of x. So x is approaching to 0, 1 over 0 lah. Sorry, 1 over cosine 0 is 1. Okay, cosine 0 is 1. So 1 over 1 is, so this one is also 1. Betul tak jawapan dia 1? 1.
Betul.
Betul Okay, so therefore limit x approach to 0 for x over bukan x over x cube times cotangent x. Okay, so x cube cotangent x, it is equal to 1. Okay, boleh?
Boleh.
Okay. So ini soalan number 44. Okay, so now look at 45.
Madam, 48.
48. 45 tak ada ya? Lagi soalan apa? 44, 48. Itu saja.
58.
58. Okay, so now
Dengan
kita tengok
59.
dengan 59. Ni ada ya. Okay, so now look at this question 48. Limit x approach to 0 for exponent of x plus x. The whole thing to the power of 2 over x. Okay. So kita tengok limit x approach to 0. Limit x approach to 0 for exponent x plus x, okay, times 2 over x to the power of 2 over x. to the power of 2 over x. Okay, so find the limit exponent of x plus x where x is approaching to 0. So this one, exponent you akan dapat 1 plus 0. 1 plus 0. So here we have 1. Ataupun kita boleh katakan the whole thing for this one is so exponent x plus x. This one, the whole thing is 1 plus 0. 1. This one, 2 over x, where x is approaching to 0, we have 2 over 0, so 2 over 0 is infinity. Okay, so now we have 1 to the power of infinity, which is product, indeterminate product. Indeterminate power, sorry, indeterminate power. Okay, so the indeterminate power, we have a few procedure to solve for indeterminate power. So the first one, we need to introduce the dependent variable. So let y. So y here is exponent of x plus x. So to the power of 2 over x. And next, we need to take natural log left hand side and right hand side. Okay, so this one, by using property of logarithmic. So we can bring 2 over x in front of this natural log. Then here we have 2 over x, natural log exponent of x plus x. Okay, so find the limit. For natural log y, so it means that we find the limit x approach to 0 for 2 over x times natural log of exponent of x plus x. So you cari limit dia, so 2 over 0, we have infinity. So natural log exponent of x plus x, 0, 1. So natural log 1. So yang ni akan dapat 1 dalam ni. So natural log 1 is 0. So it is equivalent with infinity times 0. So this one is about indeterminate.
Madam.
Product. Yes.
Macam mana dapat loan, madam?
Okay, untuk natural log ni, kita letak di sebelah kiri dan juga kanan. For ln, you just take the ln. Actually, we want to use logarithmic property to turn down for this index. Untuk bawa power ni ataupun index ni ke bawah. Jadi teknik dia adalah kita gunakan hukum logarithmic. So hukum logarithmic adalah berdasarkan natural log b power of a. It is also equivalent with a natural log of b. Okay. So that is why we need a natural log. So kita perlukan natural log ini. So bila nak gunakan natural log, bila nak letak sebelah kanan kat sini, sebelah kiri pun you kena letak jugalah. So for this natural log, how do we get the natural log? We just take natural log left hand side and right hand side. Kita just ambil saja natural log tu dan letakkan di sebelah kiri dan juga kanan. Okay? Faham ya?
Okay, madam.
Okay.
Faham.
Alright, very good. Yang lain ada soalan? Okay, tak ada. Okay, good. Alright, so this one is indeterminate product. So if we have indeterminate product, then we need to rewrite into a ratio. Then here we will have limit x approach to 0 for 2 times natural log exponent x plus x over x. Okay. So you cari limit ni. Natural log exponent x plus 1. Okay, x plus 1 plus exponent x plus x. So maknanya you cari exponent 0 plus x plus 0. Exponent 0 plus 0. So, kita akan dapat 1 dekat sini. Okay, so exponent 0 is 1. So, plus 0, 1 plus 0 is 1. Okay, and then natural log 1. Berapa dapat natural log 1? Yang ini 0. Okay, so maknanya kat sini kita dapat 0 over 0. So, natural log 1 is 0. So, 0 times 2, we have 0 over x. So, x is approach to 0. So, means that x is 0. Okay. Dia menghampiri ke kosong. Jadi, kita ambil nilai tu. Alright. So, next apply L'Hopital's rule. By differentiate for numerator and denominator. This also equivalent with the limit x approach to 0, derivative respect to x, on 2 times natural log exponent of x plus x over the derivative respect to x on x. Okay, so differentiate, then you akan dapat 2 over exponent of x plus x. So, multiply inside here. Yang dalam ni pun you kena differentiate. So, derivative respect to x on exponent of x plus 1. So, here we have exponent x plus 1. Okay? Plus 1. Alright. So, now yang ini derivative respect to x. On x, we have 1. You akan dapat 1. So, tak perlu letak lah. Dapat 1 macam ni. Okay. Alright. So, selesaikan. Ni tak letak pun tak apa. Kalau you tanya mana perginya, sebab kita differentiate respect to s on x, kita akan dapat 1. Alright, so next, you cari limit ataupun it is also equivalent with the limit x approach to 0 for exponent of x plus 1 over exponent of x plus x. Okay, so you cari limit x approach to 0 for exponent of 0. Kita akan dapat 1 dekat sini. So, 1 plus 1 is 2 over. So, this one is also 1. So, 1 plus 0 is 1. So, the answer here is 2. Dapat 2 jawapan? Limit x approach to 0 for exponent of x.
Benda bukan 4 ke?
4
Sebab ada 2 di hadapan.
Ada. Kat mana tu? Oh ya, lupa. Tak nampak. Kejap. 2. Kenapa 4? Ni 2 sini kan? 2 dekat sini. Alright. Okay, so yang ini you differentiate. Ambil satu ni, kita differentiate dia. Dapat natural log exponent of x plus x. Sama juga dengan, okay, so 2. 2 di situ, multiply. With natural log, you differentiate for natural log exponent of x. You akan dapat 1 over exponent of x plus x. And then multiply inside here respect to x. Then we will have exponent of x plus 1 dekat sini. Alright. So we'll simplify. You akan dapat 2 times exponent of x plus 1 over exponent of x plus x. Alright. So, saya masukkan dalam ni. Sepatutnya ada 2 di sini kan? 2. 2 times. Ini 1. 1 plus 1 is 2. 2 times 2 is 4. Ya, betul-betul. Kita akan dapat 4 kat sini. Okay, we have 4. Right, very good. Okay, so kena ingat yang ini adalah indeterminate power. So, untuk indeterminate power, at the end of the day, the answer you need to take exponent left hand side and right hand side. Okay, so therefore, limit x approach to 0 for y, it is about limit x approach to 0 for exponent natural log y, and it is equivalent with limit x approach to 0 for exponent natural log y. Kapan dia lah? Adalah exponent 4. Okay, so atas ni dia adalah actually this one is a limit x approach to 0 for natural log y. Okay, so kita nak y saja. So soalan ni adalah limit x approach to 0 for y. So what is y? We have declared y is exponent of x plus x to the power of 2 over x. Okay. So, bila sebelah kiri you letak exponent, sebelah kanan pun you kena letak exponent. Okay, so now the answer here is exponent of 4. Okay, ada soalan?
Okay, ada.
Okay, good. Yang lain boleh ya? So next, yep. Aha. Ada soalan?
Saya tak faham kenapa dia jadi lon y, madam.
Kenapa jadi ln y kat sini?
Tak. Yang kat bawah tu. Limit
Ni.
i lon y.
Okay. Right. So now sebenarnya kita nak limit as approach to 0 for y. Ini soalan kita. This is the question. The question asks you to find limit x approach to 0 for exponent of x plus x to the power of 2 over x. So this one, yang ini yang soalan minta. Okay. So first we find limit, then we have 1 to the power of infinity. So 1 to the power of infinity is indeterminate power. So kita kena selesaikan based on this indeterminate form, which is indeterminate power. So untuk indeterminate power we have about 3 procedure or 3 step. The first step, we need to introduce dependent variable. So dependent variable yang dimaksudkan tu adalah y. So we have declared that y here is exponent of x plus x to the power of 2 over x. Okay, so this one is about first step. Second step, we need to take natural log left hand side and right hand side. So kat sini yang kita letakkan natural log. Okay, so the reason why we take the natural log left hand side and right hand side, because we want to simplify for this power. Kita nak pemudahkan power ni. Okay, selagi power ni ada dekat atas ni, kita sukarlah untuk selesaikan masalah ni. Jadi, apa yang perlu kita lakukan adalah kita letakkan natural log di sebelah kiri dan juga di sebelah kanan. So, based on logarithmic, law of logarithmic ataupun hukum ln, bila kita ada natural log b to the power of a, so it is also equivalent with a to the power, it is equivalent with a times natural log of b. Okay, so ini adalah dalam hukum logarithmic, which is law of logarithmic function. Okay, so bolehlah kita bawa 2 over x ni ke depan. Satu line. Okay, so now we have natural log y equivalent with 2 over x times natural log exponent of x plus x. Okay, and then next step yang ketiga, yang ini, kita cari limit. Limit as approach to 0 for left hand side and right hand side. So first, kita dapat this one, indeterminate product. So indeterminate product, kita selesaikan, rewrite into a ratio. And we have this answer, which is 4. Okay, so sekarang kita nak jawapannya dalam limit as approach to 0 for y. Kita tak nak ada natural log dekat situ. So kita kena naturalkan yang ini dengan meletakkan eksponen di sebelah kiri dan juga di sebelah kanan. So in index and logarithmic function, exponent natural log y, it is equivalent with y. Ataupun exponent natural log of a, it is equivalent with a. Okay? Faham So, y, it is also equivalent with exponent natural log of y. So, bila you letak di sebelah kiri, di sebelah kanan pun you kena letak jugalah. So, kita akan dapat exponent of 4. Therefore, the answer for limit s approach to 0 for exponent of x plus x to the power of 2 over x is exponent of 4. So, ini jawapan dia. Faham?
Okay, faham.
Jelas?
Jelas ada.
Okay, very good. Yang lain ada soalan? Tak ada ya? Okay, good. Alright, so last one, 50. Second last. 58. 58 limit as approach to 2 for 1 over x squared minus 4 times square root x minus 1 over x squared minus 4. Okay. So this one kalau you cari limit dia 1 over x squared minus 4. We have 1 over 2 squared. So 2 squared is 4. So 1 over 4 minus 4, we have infinity kat sini. So kat sini pun you akan dapat 1 over 0. So 1 over 0 is infinity also. So this one is about indeterminate. Apa indeterminate apa? Indeterminate difference. Okay. Right. So yang ini, untuk yang ini indeterminate difference, we need to combine the terms. Okay. So kita tengok 58. Last So ini you boleh buat sendiri kot. Jawapan ni kat belakang. As your exercise Okay, so
Boleh.
now look at 58. So 58. Limit x approach to 2. Sekejap tu. Betul-betul. Limit x approach to 2. For 1 over x squared minus 4 minus square root of x minus 1 over x squared minus 4. Tadi kita dah dapat infinity minus infinity, which is indeterminate difference. So we need to combine the terms. Combine. So here we have a limit x approach to 2. So combine ni pecahan kan? Pecahan with ratio with the minus operation. So if we have a plus operation and minus operation for the fraction, so we can combine, but we have one condition here. The condition, denominator must be equal. Mesti sama. And then kita boleh combine. So kalau kita tengok kat sini, denominator dia adalah x squared minus 4 and the other one is also x squared minus 4. So that we can combine, then we have 1 minus square root of x minus 1 over x squared minus 4. Okay. Ini adalah pecahan lah. Pecahan biasa je ni. Alright, so cari limit dia. So for this limit, x approach to 2. So 2 minus 1 is 1. So square root 1 is 1. 1 minus 1 is 0. So yang ni akan dapat 1. So 1 minus 1 is 0. So untuk yang ni, x squared minus 4, where x is approaching to 2, we have 4 minus 4. So 4 minus 4 is also 0. Okay, so next you just apply L'Hopital's rule. Okay ke kelas?
Okay.
Okay, madam.
Okay, very good. Okay, so kita differentiate for numerator and denominator. So limit x approach to 2 for 1 minus square root x minus 1 over x squared minus 4 equal limit x approach to 2 derivative respect to x on 1 minus square root x minus 1 over derivative respect to x on the x squared minus 4. So you differentiate yang ni dapat kosong lah sebab ini constant. So now we have a limit x approach to 2. Okay, so negative 1 over 2. So yang ini power dia 1/2. 1 over 2 minus 1 is a negative 1 over 2. So power negatif maknanya dia berada di bawah lah. So ini double check 1 over 2 square root x minus 1. Okay. And then over, you differentiate yang ini. X squared minus 4, we have 2x. Alright. So sekarang cari limit dia. So 1 over 2 times x minus 1. So x minus 1, x is 2. 2 minus 1 is 2 minus 1 is 1. So square root of 1 is 1. Okay. Alright. So jawapan dia adalah berapa you dapat ni? Equivalent with 1 over 2 over 2 over 4. Jawapan dia apa? Is it 2?
1/8.
1/8? 1 per berapa? 1 per... Ini 2 minus 1 is 1. So square root of 1 is 1. So 1 over 2 over 2 times 2 is 4. And it is also equivalent with 2. Betul jawapan 2? Hah?
Kan 1/8 ya, madam.
8
Kira kat kalkulator dapat 1/8.
8 divided by 4. Betul lah 1/8. 1 over 8. Yes. Betul. So limit x approach to 2 for 1 over s squared minus 4 minus square root s minus 1 over s squared minus 4 equal to 1 over 8. Okay, so ini jawapan dia. Okay, ada soalan tak? Dapat tak jawapan? Dapat kan? 1/8.
Dapat.
Okay.